guys. So as I mentioned in the previous videos that we can use calculus to solve system of pulleys, right? So we're going to use that technique only when a system of pulleys is connected by a single string, or sometimes we can solve system of pulleys where we have two strings using this technique, right? So if a pulley of system is connected by a single string, please try this method, and this method will get you to the answers in a quick way, right? So before we begin, I want to revise you on the concept we learned under applications of derivatives. We learned that we can represent instantaneous velocity and instantaneous acceleration using derivatives, right? So if we talk about the motion of a particle, now what is the speed or velocity? Velocity is defined as velocity of a particle is defined as change of displacement, change in displacement divided by time, right? So we have a particle here, and we are going to measure the displacement with respect to a fixed point or with respect to Earth. Okay, so we know that when we are dealing with the system of pulleys, we have to represent acceleration of each particle or each object with respect to Earth, right? Relative to Earth, right? So here, what we do here is that we measure the displacement of the particle respect to a fixed point, right? Then after delta t time, measure the displacement of the same particle with respect to the same point, okay, or with respect to same point with respect to same level, whatever it is, okay. Velocity change. Now velocity in this case, delta x, so let me call it delta t, delta x. So here x, change of displacement is x plus delta x, final location minus initial location divided by delta t, right? Delta t. So this gives us, sorry, delta t, delta x over delta t. This is our velocity, right? So you learn that instantaneous velocity is therefore defined as limit of this entity as delta t goes to 0. So this is the definition of the derivative dx by dt, right? So we use this notation especially when it comes to a pure mathematics, but when it comes to applied mathematics, writing this whole thing takes time. So instead what we do here is that we represent the variable that changes, or the displacement, and put a dot on top of it, right? This means derived only once. So similarly acceleration, instantaneous acceleration. So this is the velocity, average velocity. This is the instantaneous velocity. Okay, these two are different. Instantaneous acceleration of a particle, or the acceleration of the particle at that instance, is defined as limit. We don't need to use this one. So dv by dt. So what is dv by dt? If I differentiate this with respect to t again, I get d squared x by dt squared, right? Simply put, again, instead of writing this whole thing in applied mathematics, we use this notation. Put the variable x and put two dots. So two dots represent differentiated twice. So this is actually the acceleration, how you represent acceleration. Now when it comes to system of pulleys, we need to specify the acceleration, right? So this is the technique that we are going to use, right? So now this is the theory part, right? There's not much to learn about it. You have learned this already. Now let's see how to use this concept, to solve system of pulleys. So I'm gonna give you just one example, and we'll see many examples during the live discussion. So we'll start with a simple example, pulley system. Right, so look at this example. This is simple, the most basic one that you get. You can use physics to solve this one. We saw that earlier. So we know that if one particle moves downwards with a certain acceleration, the next particle moves upward with the same acceleration, with the same magnitude, but the directions are different, right? So now we're going to use calculus technique. This is what we're going to do. Now acceleration of each particle can be represented like, so suppose the displacement, using the displacement, right? If you know the displacement of a particle with respect to fixed point, then that variable, two dots on top, gives you the acceleration. Now this is what we are going to do. Now we have one particle here, so m1 and m2. So let me just represent m1g and here m2g. This is the basics. Then you have to represent the tension T, provided that the string is inextensible string, right? Inextensible light string. So tension is same. That is also because of this pulley is smooth. This is a smooth pulley. So I'm not going to write that down. It's a smooth pulley fixed to a ceiling or fixed to the earth, right? Okay. Now next thing is that we have to represent acceleration. Now this is a simple example. You know that we can directly represent acceleration of these particle, of each particle with respect to earth, right, relative to earth. But just to tell you how to use the techniques, calculus techniques, let me show you how to do this one. Now we're gonna come up with a reference point. The thing is that we are going to take into account the length of the string. We are going to take into account the length of the string. That's what we are going to do, right? So I'm going to get a level, right? Certain level. So this level will not change even though the particle moves. This level will not change. Level is there, right? It's fixed to earth, right? This is the level. Now I'm going to represent acceleration of the particle with respect to these levels, right? Before we represent the acceleration of the particle, we have to represent the displacement. So what is the displacement of this particle? Right? This is the displacement of this particle. Okay? From here to here. That's the displacement. And displacement of this particle. Right? This is the other displacement of this particle. Okay. Right. So we are going to give them names, variables. Now these are two different variables. So I am going to mark this as x and I am going to mark it as y. X displacement and y displacement. Okay. Next what we are going to do here is that we are going to now do this. I am going to mark the acceleration of this particle in terms of x. Now where do I mark the acceleration? In which direction? Acceleration is, you know that x double dot is the acceleration. X double dot is the acceleration of this particle. X double dot is the acceleration of the particle. Okay, oh, we can mark it here. X double dot is the acceleration and the y double dot is the acceleration of this particle. What is the direction? What is the direction of the acceleration? Now here's the thing. We mark the acceleration, direction of the acceleration in the direction of increasing x. Increasing x. Now which direction when you move, x will increase, right? If you move in this direction, x will decrease. X will decrease. If you move in this direction, move downwards, x will increase. So we mark it in this direction. Right? එහෙම එකපාරට ඔලුවට එන්නේ නැත්තම් මේ line එක තියෙන පැත්තට නෙමෙයි අනිත් පැත්තට mark කරන්න. එච්චරයි. Similarly, for the same variable we mark it in this direction. Right? This is the acceleration. So now we imagine the particles are accelerating. This only works for accelerating. Okay. Now I want to get the connection between x and y variable. How do you get the connection between x and y variable? But in terms of the length of the string. Now suppose this length, this part is L naught, right? and L is the length of the string. L is the length of the string, length of the string, right? If this is the case, you know that these length, right? This length and this length will keep on changing, but this length is constant. මේ කෑල්ල කවදාකවත් වෙනස් වෙන්නේ නැහැ. මේ length එක same. මොකද හැම වෙලාවෙම touch වෙලා තියෙන්නේ pulley එකට string එකකින්. හින්දා මේ length එක always same, but these lengths will keep on changing. But we can get a connection between x and y by this. L must be equal to what? X plus L naught plus y plus L naught plus y. Now what we are going to do is we are going to use, if you can remember implicit differentiation, we are going to differentiate this with respect to time, right? Because x and y variable are changing, L and L naught will not change. L will not change. Why? Inextensible string එකකින්ද ඇදෙන්නේ නැහැ. ඒ හින්දා total length එක of the string is constant. Time එකත් එක්ක වෙනස් වෙන්නේ නැහැ. right? Time එකත් එක්ක වෙනස් වෙන්නේ නැත්නම් derivative එක 0. මේ length එක L naught, it does not change with time, so that will give you a 0 value as well. Now derive this with respect to time. දැන් හොඳට මතක තියාගන්න මම මේක එක ස්ටෙප් එකක් පෙන්නනවා කරන විදිය. ඒ ස්ටෙප් එක විභාගෙදි කරන්න අවශ්‍ය නැහැ. නිකන් ලියන්න තියෙන්නේ. මම පෙන්නන්නම් theory part එක මොකද්ද කියලා. Now I'm going to derive this whole thing with respect to time. L x L naught y. This is what I'm going to do. Right. dl by dt, dx by dt, dl naught by dt, dy by dt. Okay. Now we know that dl by dt, this part will not change. And we can, this is the rate of change of the length of the string. The length of the string change වෙන්නේ නැහැ. ඉතින් අනිවාර්යෙන් rate එකක් නැහැ. කියන්නේ this part is 0. මෙයා මට ලියන්න පුළුවන් x dot කියලා. මෙයා also 0. This I can write y dot. Now we get a relationship between x dot and y dot. What is x dot? X dot is the velocity of the particle. මේ particle එකේ velocity. y dot කියන්නේ මේ particle එකේ velocity එක. දැන් බලන්න මේ calculus පාවිච්චි කරලා අපිට velocity අතර තියෙන relationship එක ගන්නත් පුළුවන්. ඔයගොල්ලෝ දන්නවා මෙයා පල්ලෙහාට යනවා නම් මෙයා ඒ velocity එකෙන්ම උඩට එනවා. බලන්න මේ x dot plus y dot equals 0. මෙයාව මේ පැත්තට ගෙනිච්චාම minus y dot එනවා. change වෙලානේ තියෙන direction එක maths වල ලස්සනට එනවා. ඊළඟට අපි ඊළඟට ආයෙ ලියනවා derive with respect to time, we derive it again and we get x double dot plus y double dot. මෙච්චර ලියන්නේ. මෙන්න මේ ස්ටෙප් එක ලියවලා හරි. මේක ලිව්වා. මේ L naught වැදගත් නැහැ. This is not important. Just write down x plus y equal එච්චර. මේ ස්ටෙප් එක ඊළඟට මේ ස්ටෙප් එක ඊළඟ මේ ස්ටෙප් එක. මේක මම කරේ මොකද්ද කියන්න විතරයි ලිව්වේ. ඒතර exam එකේ හරි ගණන් හදද්දී හරි you don't need to write this down. You can just write this and this. මෙතන නම් පටන් ගන්න ඕන. constants ඔක්කොම අයින් වෙලා යනවා. හරිද? ඒතර මේක මතක තියාගන්න. This is the relation we obtained. So finally 0 equal x double dot plus y double dot. මේකේ තේරුම මොකද්ද? x double dot වලට equation එකක් අරගෙන y double වලටත් equation එකක් අරගෙන මේ දෙන්නගේ sum එක ගත්තොත් definitely 0 වෙනවා. දැන් අපි බලමු මේ ගාන හදන්නේ කොහොමද කියලා. Right. So let's put f equal ma like all the time for m1 particle හැම වෙලාවෙම acceleration එක direction එකටම දාන්න බලන්න downwards. Right. So we have m1g minus t is in this direction. m1 acceleration මොකද්ද? acceleration x double dot. Right. So මේ equation එක නෙමෙයි අපි පාවිච්චි කරන්නේ. අපිට x dot double dot plus y double dot ගත්තාම 0 කියලා මාක් කරන්න පුළුවන්. හින්දා I'm going to divide this whole thing by m1. m1 වලින් divide කරොත් I get t1 divided by m1 x double dot. This is my first equation. Then for m2 downwards again we have m2g minus t m2y double dot y double dot තමයි acceleration එක. දැන් f කැලි දාන්නේ නැහැ. Simple F, capital F, no. Now I divide this by m2, then g minus t over m2 equal y double dot, which is second equation. එච්චරයි. Then I sum these two up. 1 plus 2 sum කරපුවා මොකද වෙන්නේ? x double dot plus y double dot එයා 0 වෙනවා. එතකොට මම මෙතනදී sum කරාම 2g minus මෙතන it should be t, sorry. T is common, I take out t, so I get 1 over m1 plus 1 over m2. මේ side එකේ x double dot plus y double dot m. Right. So this part is 0. We found it out. We determined this already. So this part is 0. 0 2g minus t 1 over m1 plus 1 over m2. Right. Then what is t? t එක එහා පැත්තට ගියාට පස්සේ t එකට ආන්සර් එනවා 2g m1 m2 divided by m1 plus m2. Right. So when you use this method, you can directly obtain the tension. Right. Tension එක ගන්න ක්‍රමයක් තමයි making එන්නේ. මේ method එක කෙලිම tension එක ගන්න පුළුවන්. Once you obtain the tension, then you can obtain each acceleration. හරිද? එතකොට මේ ක්‍රමය හොඳට බලා ගන්න අපි ඉස්සරහට ගණන් හදමු. මේක simple ගණන්, මේ වගේ ගණන් වලට මේ ක්‍රමය පාවිච්චි කරන්නේ නැහැ. සාමාන්‍ය basic method එක පාවිච්චි කරන්න definitely. System of pulleys ආවට පස්සේ මේ method එක පාවිච්චි කරලා මම ගණන් හදන්න.